Good morning, guys. The videos which I sent yesterday was not complete. When I checked in the evening, it was only almost one third. But when we took the day before yesterday, it was 4.5 minutes and it was not complete. That's why I thought of sending another video which will give you a clear idea about the experiment. The objective of this lab is to find out the head loss due to friction in pipes. Head loss due to friction in pipes. There are two types of friction I told you in the beginning before. What is a minor loss and major loss? Minor loss experiment we already done before. Like the losses in vents, elbows, mitre, valves. Because of those, the loss of head because of those fittings. But major loss is because of friction in pipes. Loss of friction, loss of fluid friction in pipes because of friction. Friction, when the friction is inside, too much friction, there is more losses, head loss. This experiment is, the important parts of this experiment is, this is the pipe friction experiment equipment, where these are the 5 different size of pipes. This is the smallest one and this is the biggest one. In between there are 3 different sizes. And the 4 pipes are smooth pipes. Inside surface is smooth. Inside this one is smooth, inside here, and last one also. But this pipe, inside surface is rough. I told you before, the rough surface will give more head loss because friction is more, the resistance to flow is more, so more friction and more head loss. And these are the 2 pressure tapping points, one here, one here. The flow is coming from here, and this distance is 1 meter for each pipe, 1 meter. So this is a sensor here, one sensor here. This sensor is connected to the computer through a driver. The driver, the software and this hardware will give you the necessary reading here also. So we can take the readings manually as well as from the computer also, and we can compare the results. So here other important parts of the equipment are, this is the hydraulic bench. This is also Armfield. This is also Armfield USA, manufactured by Armfield. And this consists of a tank, collecting water tank, and there is a pump here. This pump with an electric switch, and there's a control valve also. The control valve is to regulate the flow rates. You can adjust the different flow rates. We can by opening the valve more, little like that, we can adjust more flow rate. And when you switch on the pump, the liquid water will flow through the pipes. And when it passes through the pipes, first thing is to purge the lines to remove the air bubbles. If there is air bubbles, we will not give accurate results. So first purging the lines, and then we will select one pipe, first one. Suppose we take this line, then you open this valve. All other valves should be closed like this, closed. These are called isolation valves. Once this is closed and this is open, the liquid will come from here and goes, and you can find out the head loss from this point to this point. The distance between these 2 points, I told you earlier, is 1 meter, and the size is given in the literature. Once we know the size, we can find out the area of the pipe, and we can find out the velocity. How do you find the aero velocity? Because the collection tank for particular flow rate, we can find out time taken for 5 liters of water, and that quantity divided by time taken will give you the flow rate. And once you know flow rate, applying the continuity equation, Q is equal to A area multiplied by velocity, we can find out the velocity. That velocity is equal to Q by A. And also similarly, at the same time, you can also get the results in the computer also. This computer will also give the results. Now head loss due to friction, it can be found out by applying the equation, Darcy's equation. You might have studied with Mr. Peter. Darcy's equation says HF is equal to 4F LV square by 2GD. So here the friction factor you can find out from the Moody's diagram. I sent the Moody's diagram graph, and from the Moody's diagram you can find out the Reynolds number. Reynolds number is equal to rho Vd by mu, rho density of water, velocity of the flow, and density, diameter of the pipe, and mu is the viscosity. Everything is given in the literature. So once you know the Reynolds number for each flow, you can find out by projecting a line, and then you will get the friction factor. So by substituting, we can find out the head loss due to friction between these 2 points. So your idea is to compare the manually find out the head loss due to friction here, and also I will give you the results which is already there in the computer also. So compare this and plot the graph and also comment on the results. This is the experiment. This is about a wide application industry, especially oil and gas industry, because pipe friction is one of the important parameters, concerns for oil and gas industry. How can you minimize, how can you reduce by selecting different size of pipes and different materials and different viscosity pipe fluids. Those things are important parameters which will govern the head loss with the friction. Hope you understand, and if you have got any clarification doubt, please let me know, and you are free to contact me at any time. Thank you so much, and have a good day.